Hello everyone, welcome once again to my YouTube channel. Last two videos we looked at the train test split function of scikit-learn library. We also looked at the different models we were using, and we also looked at the standard scalar and so many other things. In this video, we will look at how to run the code and look at the result we are going to get from the code, that is from running the model. And we'll also explain in details what the result of executing the code means to our prediction, to our model. So sit back, relax, and enjoy the teaching.
This first line of code is what we fit the 80% of the data into. This line of code is what we fit the 80% of only the X, that is the feature variables. So it's predicting the Y. So the answer you should be getting is that instead of 114, now you're getting 100 for linear regression, you're getting 110 for SVR. It will do like that for the whole rows for the Y. So this your Y is going to contain an array of results for your Y, which you call it predicted Y. So now we want to check whether the Y that you predicted is exactly the same with the original Y that's supposed to be there. Don't forget the row we are using, for example. The answer for that row we have been using, for example, is 114, right? It's going to check now. This mean square error now. We are going to pass in our Y test. That's 114, 40, all those information for the Y test. That's 20% information of your Y. We'll pass it into this function, mean square error. Then this Y predict that you predicted that it should be the answer, we'll pass it into that function. So what this mean square error will do is now be comparing, okay, the Y test that linear regression got 100, right? Meanwhile, the original linear regression got 100, right? This is it, 100, right? Y predicts. Meanwhile, what is the original answer is 114. So it will now do the mathematics and calculate. Okay, keep it at one corner. It will do like that for the whole row. When it finishes everything, it will put all of them together, find the square root here, and give you the answer. That is 1. Then the second error we check, the score, R2 score, it does the same thing too. When I run it, you understand better. This round is just to round up our answer to 2 decimal places. So we print out our result for each model. For each model, we print out our result. Okay. So I think we are done. Let's take it one step at a time from the beginning now. So I think I've run this. Okay. We don't need this one. Anyway, this matplotlib, I just use it to plot to check correlation. It's just to check the correlation of the variables to see the influence of each feature on the target. For example, temperature. The influence of temperature on the people coming is very high. If the temperature is very, very low, that is everywhere is over cold, we are going to have lesser people coming. So that is just what correlation checks. It checks, okay, what is the relationship between advertisements and the number of people coming? What is the relation of? So that is how that one works. So let's focus on the model. That one is under exploratory data analysis. So let's just leave that one. So I've run this one. So this is our machine learning data set. So the data set is very clean. You can see there's no missing value anywhere. Everything is complete. So that's for that. So I also checked for duplicates. There's no duplicates, it's 0. Okay, so now look at this. Categorical column. Sorry, I didn't explain one. Look at this one. Pre-processing. I didn't explain that one. That's the final one. Okay, so pre-processing. That is, you are processing your data. Now, when you are dealing with machine learning, machine deals with numbers. Machine deals with numbers. It doesn't deal with character. So, if your data set contains words, you have to convert those words to numbers. So let's check our data sets. Where are the columns that contain words, day of the week, and weather? Now, we don't need date column. So as we go on in the code, you see I had to drop it. Okay, because day of the week is enough. We don't need that for machine learning. But if it's Power BI, we can. Okay, so we can see the two columns now that contain words, day of the week and weather condition. So let's go back to our code. Let's go back to our code. Okay. So now what this one hot function does, it converts your character, that is your data set that are in words, and converts them to numbers that your machine can understand. So this is how to do it. Encoder, you call it, then you do the encoding. You fit the categorical columns. So what I just did, I selected the column day of the week and weather condition, which is the category. I put it in this variable, categorical column. So I fit it into this function or model so that it can do the conversion. So after doing the conversion, I put my answer in a data frame. So that's just what I did here. I put my answer in a data frame. So it's want to convert those words, sunny, rainy, Saturday, to numbers. So this line of code is what does the conversion. This line of code, we are calling the function to come, and then we fit the model, we fit it with this information, categorical. That is the fit and transform it. So it will fit it into the encoder, this encoder model, which is this, and transform it. We give you a zeros and ones, zeros and ones, zeros and ones. So we'll put it in the data frame in a table format, because it comes, the result of this comes as an array. So we are putting it in a table format here. Look at it. One hot encoder, look at it, we're putting it in the data frame. So this get features column, you can see I explained it here, is what we get the names of this categorical column, day of the week and weather, and put it as the name of the column in our data frame. Then we added that data frame to the original data frame, df, that is the concatenate here. And we're saying you do it on the column axis, that is the axis one, is column axis. So after doing that, we have to drop the original column, that is this day of the week and weather condition. That original day of the week and weather condition column, we have to drop it. We have to remove it because we don't need it again. It has already been converted to zeros and one here. So we don't need it again. So that's how we have to drop it. So let me run the code. So what that encoder did, you can see what it did. Friday. Look at our target column, is still here. Look at it. So 71. So look at our day of week, Friday, is now 0.0. See Monday. You can see all of them are in numbers. Now Saturday. So what it does, for example, if you filter the weather condition column, we have sunny, we have rainy, we have, so it will pick each word and put it in a column, then give the zeros and ones for each row for only that word. So look at this one now, Friday. So it gives zeros and ones. So what it does now, it will pick cloudy for row 2. Don't forget, we now have this column as cloudy column. Now let's say this column now is cloudy column. The answer, is it cloudy? Yes. So under this cloudy column, you have 1. For row 3, the answer, is it cloudy? No, it's rainy. You have 0 there. So any row that has cloudy, for this cloudy column, you have 1 there. And if it is not cloudy on that row, you have zeros. Next column will be for rainy. This next column will be for rainy. Now, to check. Okay, the first row, what is there? Cloudy, we are going to have 0. The second row, what is there? Rainy, we have 1. Rainy, we have 1. Cloudy, 0. So that is how one-hot encoding works. So it will pick all the individual unique information of that column and separate it into columns. Then to start with checking zeros and ones, zeros and one. Same thing applies to the days of the week. It will have column for Wednesday. So it's today, Wednesday, 1. Today, is it Wednesday? No, 0. It will have for Wednesday, Thursday, Fridays, like that. So your data set will now expand. So initially, we're having how many rows? How many columns? Let's check. Initially, we're having this number of columns, 12 columns here. But now, look at the number of columns we're having. Date, holiday indicator, temperature, precipitation. It now splits the days of the week column. We are now having Friday separate, Monday, Saturday. The same thing comes to weather, cloudy, rainy. So if you check it, we'll be having, I think, 22 columns. Look at it here, 22 columns for the same number of rows. So this code 11, we are dropping the dates column. We don't need it. So I've run the code. So that has plot the correlation matrix. So I had to separate, I had to bring out all the column header. All the column header. That is what I had to do. So now, this is where we separate our data set into X and Y. So as I've said earlier, our Y is only the pack visit count column. So that is what we did here. And our X is every other column. So what did we do here? We just said, for you to get the X values, just drop the pack visit count column. Just drop only that one. You know, once you drop that pack visit count column, every other column is your X. That is your feature variable. So this is the standard scalar function. Don't forget what standard scalar does. It makes your data to be in a normal distribution. That is, it should be in a arc form. So that is what this code does. So it fits the model and transforms it. Then this is our splitting. These are our splitting tags. And this is our model tag. So let me make sure I run it so that we can see our final results. We are almost there. We are almost there. Okay. So let me run this too. Yes. So now let's run our model to see our results. So our model is running. Voila. Here's our results. So root mean square error for linear regression is 1, 2, 2. You can see it's telling you that on average. Don't forget what it's telling you, mean. So on average, it is having 1, 2, 2 for linear regression. But its score is 0.9, that is 95%. But for the SVR, is mean, that is mean is 125, while the score is 0.9. Now, how do we know the model that did well? When you are dealing with root mean square error, the lower your answer, the better. So between 122 and 125, 122 is lower than 125. So linear regression is doing well based on the root mean square error. Now let's check our R2 score. You can see our R2 score. Linear regression is 95%. Meanwhile, SVR is 94%. So obviously, in our model, linear regression carries the lead. So the winner is linear regression. So if root mean square is good, score most definitely will be good too. Yes, since the root mean square of linear regression is lower, which makes it better, is lower than SVR. So automatically, the score will calculate the linear regression as higher too, because the lower the root mean square, the higher the score. Linear regression is the winner here. Let's use 1, 1, 0. Linear regression predicted 110. So what is the difference between 110 and 114? It's just 4. Number 4. So it will take the 4, check the next row. What is the difference in the values? Pick the number. What's the difference in the value? Pick the number for all the rows, then find the mean. That is just it. The prediction model does in machine learning is, in 2026 now, they predict weather conditions. Is it not so? When you are watching news, they will tell you whether tomorrow will be rainy. You can take those information now and say, give it the date, and say, okay, for so and so day in 2026, with this information, in 2026, you already know the days that are holidays, at least, except the impromptu holidays like COVID-19 old. But we already know the days that are holiday. We know Easter is holiday. So you already have that information in advance. So you feed it with that new information. Obviously, once you know the COVID-19, the Easter day, you already know the day of the week of that day. Let's say it's Wednesday. You already know the predicted temperature like that. You can predict and say, okay, it will be cloudy based on this thing. You already know whether it's a weekend. By checking your calendar, you know this information. You already know ahead whether school will be on vacation because we have school calendar already. Then you will know, okay, am I going to do promotion, advert? Am I going to do an advert? If I add advert there, fine. If I don't have advert there, I will put 0 for that column. Then is there going to be a new pack fixture on that day? We'll put it there. If there's not going to be a new pack feature, we'll put 0 there. If there's going to be a new pack feature, we'll have 1 there. So based on this new information now for this row on that day, February 28th, 2026, this is the predicted weather condition. This is the predicted humidity. School will not be on vacation that day, so it's 0. We're not planning to do any advertisements. There's not going to be any special pack features. Put it to the model and tell the model, how many visitors are we going to have on that day? The model will not tell you the number of visitors you have that day. That's how machine learning works.
Okay, let me explain one more time. Let me summarize all I've been saying. Now, I discovered some people get confused about machine learning, that okay, since machine learning is doing prediction and we're saying we're trying to predict here in all we've done today, so we're supposed to see a new column predicting the number of visitors we're going to have next year, since the data set has the total number of visitors from previous year. And we're saying we are predicting, so the result we should be having from all we've done today should be a new column where we will have predictions, new predictions for the next year. But no, it's not so. This first stage is the stage of building the model. So all we did today for now is that we built the model, and this model can be able to predict future events, that is future number of visitors. How? By getting new information and putting it into the model. Now, what do I mean? For you to be able to finally predict, now take note, all we did in this video and the previous 2 videos, all we did with all the code is just to create our model, develop our model, a model that can predict number of visitors that will visit a park in subsequent years. That is all we did. It is not predicting yet. Not like as if it didn't predict. Take note, we tested the model with parts of the data to see its efficiency in predicting. So where those error come into place, that is RMSE and R2 score come into place, is that it's just trying to check how well this model is doing its work. What is the work of this model? Is to predict. So what the R2 score and RSME metric is doing is just to make sure, okay, when we finally deploy this model, it will perform very well. So those score are just testing to check how efficient the model is. So the final result we got when we ran the code is not the prediction. The final result we got, which is the RSME and R2 score, is just the result of checking if the model will work fine. So we can see that when we looked at the result, we can see that the linear regression score was higher. So the meaning of that is that if finally we want to deploy this model, we will use the linear regression to deploy the model. That is what it means. So when we finally deploy the model, that is when we will now talk of predicting the number of visitors that will come in 2026. So feel free to drop your question in the comment section. I will treat it as much as possible. Subscribe to stay up to date with our latest video, and you will learn more on machine learning. You will see how the machine learning model will be deployed and so many other things. Thank you.